Good morning, ma'am. This is Bhavya Jha of first year, and today I am here to give a presentation on problem using Maclaurin's theorem and differentiation. Importance of Maclaurin series. Functional approximation. Maclaurin series provides a way to represent wide variety of functions as infinite series expansions centered around zero. Solving differential equations. Maclaurin series often plays a crucial role in solving differential equations, especially in physics and engineering. Understanding function behavior. Maclaurin series helps in understanding the behavior of functions around a specific point, that is zero in the case of Maclaurin series. By expressing functions as these series expansion, it becomes easier to analyze their properties such as convergence, divergence, and behavior in the neighborhood of the expansion point. So given the question, show that log of 1 plus e raised to the power x is equal to log 2 plus x by 2 plus x square by 8 minus x raised to the power 4 by 192 plus and so on. And finally deduce that e raised to the power x upon 1 plus e raised to the power x is equal to 1 by 2 plus x by 4 minus x cubed by 48 plus and so on. So let me explain the approach of my answer to this question. So as we know, using Maclaurin series, we can show the above problem and find after getting the problem solution, what we do is we just apply differentiation and we can reduce e raised to the power x upon 1 plus e raised to the power x is equal to 1 by 2 plus x by 4 minus x cubed by 48 and so on. So the step 1 of solving this problem is assumption. Log 1 plus e raised to the power x is assumed as f of x, and then instead of x we place 0 to find f of 0, which is equal to log of 1 plus e raised to the power 0. So log 1 plus 1 is equal to log 2. Now a point to keep in mind is log 2 is constant. So when we differentiate it, we get log 2 differentiation as 0, as the differentiation of any constant is 0. Now we find f dash x by differentiating f of x. So the differentiation of any logarithmic function is 1 upon the variable. So now we get 1 upon 1 plus e raised to the power x, and by applying chain rule we have the differentiation of 1 plus e raised to the power x as e raised to the power x. So we get the final value as e raised to the power x upon 1 plus e raised to the power x. Now we find f dash 0. So e raised to the power 0 upon 1 plus e raised to the power 0 is equal to 1 upon 1 plus 1, which is equal to 1 by 2. Now the step 2, we find f double dash x. This is by differentiating f of x once more. So using u by v principle, we differentiate it to u by v differentiation is v u dash minus u v dash upon v square. So we apply the same formula here to get 1 plus e raised to the power x into e raised to the power x minus e raised to the power x into e raised to the power x upon 1 plus e raised to the power x whole square. So finally we get e raised to the power x upon 1 plus e raised to the power x whole square. Now instead of x we keep 0 to get f double dash 0 as e raised to the power 0 upon 1 plus e raised to the power 0 whole square to get 1 upon 4. Now the step 3 is differentiating f double dash x to get f triple dash x. Now again we apply u by v principle, that is v u dash minus u v dash upon v square to f double dash x, and we get e raised to the power x into 1 minus e raised to the power x upon 1 plus e raised to the power x taken 3 times. Now instead of x we keep 0 to get f triple dash 0 as e raised to the power 0 into 1 minus e raised to the power 0 upon 1 plus e raised to the power 0 taken 3 times to get the final value as 0. This is because e raised to the power 0 is 1 and 1 minus 1 gives us 0. So the entire function becomes 0. Now the step 4 is quite lengthy because now we differentiate f triple dash x once more, and we apply the same formula, that is u by v differentiation, and finally after finding the entire value we get f differentiation 4 times to get e raised to the power x whole into 1 plus e raised to the power x into 1 minus 2 e raised to the power x minus 1 minus e raised to the power x into 3 e raised to the power x whole divided by 1 plus e raised to the power x taken 4 times. Now instead of x we keep 0 to get e raised to the power 0 into 1 plus e raised to the power 0 into 1 minus 2 e raised to the power 0 minus 1 minus e raised to the power 0 into 3 into e raised to the power 0 whole divided by 1 plus e raised to the power 0 taken 4 times. Now e raised to the power is e raised to the power 0 is taken as what we say is individually, and finally we get the answer as minus 1 by 8. In the step 5, we write all the derivations that we made in a single paper. That is, f of 0 is equal to log 2, f dash 0 is equal to 1 by 2, f double dash 0 is equal to 1 by 4, f triple dash 0 is equal to 0, and f 4 dash 0 is equal to minus 1 by 8. Now we can just solve it up to f 4 dash 0 because up to 4 terms answer is valid. So moving on to step 6, this is a very crucial step because in this step we are going to apply Maclaurin's theorem. So we know that Maclaurin's theorem is f of x is equal to f of 0 plus x into f dash 0 plus x square by 2 factorial into f double dash 0 plus x cube by 3 factorial into f triple dash 0 and so on. This goes on up to infinity. Now putting the values that we derived in the last slide, log of 1 plus e raised to the power x is equal to log 2 plus x into 1 by 2 plus x square by 2 factorial into 1 by 4 plus x cube by 3 factorial into 0 plus x raised to the power 4 upon 4 factorial into 1 minus 1 by 8 and so on. Finally, we get the answer as log of 1 plus e raised to the power x is equal to log 2 plus x by 2 plus x square by 8 minus x raised to the power of 4 upon 192 and so on. Now, in the step 7, we differentiate on both the sides to deduce the final value. That is, differentiation of log 1 plus e raised to the power x is e raised to the power x upon 1 plus e raised to the power x. This is solved by using the chain rule. And differentiation of log 2, since it is constant, is 0. Differentiation of x by 2 is 1 by 2. Differentiation of x square upon 8 is 2x upon 8. Differentiation of x raised to the power 4 upon 192 is 4x cubed upon 192 and so on. Finally, we deduce that e raised to the power x upon 1 plus e raised to the power x is equal to 1 by 2 plus x by 4 minus x cubed by 48 and so on. Now the conclusion that I made is, using Maclaurin's theorem and differentiation, I was able to solve the above problem successfully. With this, I would like to conclude my presentation. Thank you. This is the presentation by Bhavya Jha from Computer Science and Engineering Department, first year. Thank you.